It is a substance of paradox, infinitely fragile, yet fundamental to our modern world. We look through it, drink from it, and interact with it 1,000 times a day, often without a second thought. This silent material frames our view, from the windows in our homes and vehicles to the glowing screens that connect us. The origin of this technological marvel, however, is surprisingly elemental. Nothing more than ordinary sand. Annually, more than 60 million tons of silica sand are drawn from the earth, beginning a journey of profound transformation. These silent grains are destined for sprawling, high-tech factories. It is here, inside the largest glass factory in the United States, that an ancient alchemy is perfected by modern engineering. Through a precise orchestration of intense heat and masterful shaping, countless dull grains will become the solid, sparkling material that shapes our lives. It began with fire, sand, and a moment of pure accident. Over 2,000 years ago, around 300 BC, ancient Egyptians heating silica sand and sodium carbonate near an open flame created something the world had never seen, a solid yet perfectly transparent material. From that chance discovery, glass has quietly woven itself into the fabric of our lives. It frames our view of the world, holds our drinks, and illuminates our digital connections. Its unique internal structure gives it the clarity of a crystal, while also providing incredible resistance to heat, corrosion, and electricity. Perhaps its most remarkable quality is its capacity for endless renewal, able to be recycled again and again without losing its integrity. But within this resilience lies a profound paradox. Despite its strength, glass is notoriously fragile. It does not bend or stretch under force like metals or plastics do. When pushed beyond its limit, it offers no compromise. It shatters. This journey from humble sand to a material of such beautiful contradiction begins inside a modern cathedral of glass, where a truly astonishing transformation is about to unfold. It seems as common as the sand on a shoreline, yet its true source is far more elusive. The journey from sand to glass demands an almost impossible standard of purity, requiring silica refined to a concentration of 99%. This exceptional material isn't found on sun-drenched beaches or in windswept deserts. Instead, it is blasted from the earth in vast open-pit mines, where powerful explosives fracture dense layers of silica-rich rock. In the aftermath of the blast, colossal excavators gather the fractured stone, loading it into heavy-duty trucks. The raw debris is then hauled to a crushing facility where industrial mills relentlessly grind the rock into a uniform, fine-grained sand. This milled silica now forms the fundamental ingredient for making glass. Yet even after this violent pulverization, the sand is not yet pure enough for the demanding process that lies ahead. It must first move through a state-of-the-art washing system, a facility capable of handling 220 tons of sand every hour. Here the purification begins as the crushed aggregate is discharged into a massive hopper, which carefully regulates its flow. The sand first passes over a primary sieve, equipped with 30 mesh screens that allow only the finest particles to continue. These select grains then advance into powerful agitation chambers, where for nearly 15 minutes they are scoured by needle-like jets of high-pressure water. The resulting slurry of sand and water then flows into a spiral separation system, where the power of centrifugal force takes over, slinging heavier metallic impurities to the outside where they are filtered away. Lighter and more refined, the remaining stream is channeled through a mechanical separator to capture any final traces of iron. Once thoroughly dried, the purified sand is packed into 1-ton bags, ready for its journey to the glass factory. It begins as a mountain of ordinary sand, yet it is destined to become a vessel of perfect clarity. Inside the largest glass plant in the United States, a constant stream of raw material arrives, over 5,000 tons of silica sand each week. To this foundation, sodium carbonate and calcium carbonate are carefully blended in, altering the silica structure to lower its melting point and make the entire mixture easier to fuse. The calcium carbonate also lends a vital strength, improving the durability of the final glass. For a touch of color, specific pigments are introduced. Cobalt oxide, for instance, imparts the deep, distinctive blue seen in certain bottles. With all ingredients combined, the mixture cascades through a filtration system, a final cleansing to purge any lingering impurities before the production process truly begins. From there, the purified materials embark on a journey, carried along a vast network of conveyor belts capable of moving hundreds of tons of sand every hour in a relentless, uninterrupted flow. The sand tumbles into high-speed stirrers where each particle is violently churned, ensuring an even blend while scrubbing away any final impurities clinging to the grains. This pristine mixture is then fed into a colossal gas furnace, a chamber where temperatures climb to an astonishing 1,650 degrees Celsius, hotter than the lava erupting from a volcano. Under the watchful eyes of technicians, the incandescent material is poured into specialized crucibles. Once the crucibles are filled, their mouths are sealed to trap the blistering heat and control the fusion. Here, the air itself shimmers with intensity, forcing workers to be clad in fireproof suits and Kevlar gloves to withstand the overwhelming heat. Over the course of 24 hours, a profound transformation occurs. The granular sand is gone, replaced by a substance that flows with the viscosity of lava. What glows in the furnace is now liquid glass, a dense, radiant mass that has reached its perfect temperature and consistency. For several more hours, the glass remains in this molten state, allowing any trapped gases to escape and ensuring the absolute purity of the final material. As the glass purifies, the next phase of its journey is already being designed. Using specialized CAD software, engineers craft a digital blueprint of the mold with painstaking precision, defining every curve, dimension, and measure of thickness to meet exact specifications. This digital design is then forged into a heat-resistant metal mold, ready to receive the molten glass. The finished molds are installed onto the double-blow production line, a method perfected for creating hollow glass objects like beverage bottles and food jars. The sequence begins as a drop of molten glass, a gob, is sheared from a continuous stream. This fiery teardrop, glowing at 1100 degrees Celsius, possesses the perfect viscosity for shaping as it falls into a preliminary mold, where a jet of compressed air strikes from above, forcing the gob outward to form a hollow, bubble-like shape known as a parison. Still blazing with heat, the parison is transferred just inches away into the final mold. Instantly, a second blast of compressed air shoots into its core, stretching the soft glass until it perfectly conforms to every detail of the metal cavity. In a matter of seconds, the bottle's final form is born, a feat made possible by a symphony of synchronized valves and sensors timed to 1,000th of a second. This level of control enables the creation of hundreds of thousands of nearly identical bottles each day. Emerging from the mold, the new bottles glow a fierce cherry red, their surfaces shimmering like iron rods pulled from a forge. One by one, robotic arms glide into place with programmed grace, gently lifting each bottle and setting it onto a moving conveyor. The procession of glowing forms then travels toward a long, yellow tunnel, the cooling zone, where the temperature is lowered in gradual steps, allowing the glass to stabilize without the risk of cracking from thermal shock. This deliberate cooling can take anywhere from several minutes to tens of minutes. Once cooled, the bottles enter a gauntlet of scrutiny. A relentless network of optical sensors and high-speed cameras scans each one in real time, instantly detecting any flaw, a hairline crack, a trapped bubble, a faint scratch, or the slightest deformation, and removing the imperfect bottle from the line. The inspection then focuses on the bottle's mouth, where an automated system rotates each one as optical sensors and mechanical probes search for chipped rims or the tiniest deviation in size. The bottles that pass every test are conveyed to the palletizing area, where another team of automated robots takes command. With remarkable precision, a clamp system fitted with suction cups descends, lifting an entire row of bottles at once and gently placing them onto a pallet. A protective sheet is inserted between each layer to prevent damage during transport. Once a pallet is fully stacked, an automatic machine tightly wraps the entire block in film and applies a label with its unique production code. This entire intricate dance of machinery is monitored from a central control room, where operators track every parameter in real time, guaranteeing quality before the bottles are finally stored or shipped out to their destinations. It begins as a mountain of glittering fragments, a testament to what was broken. But in this place, nothing is truly lost. 100% of all glass scrap is reclaimed, forming shimmering hills that stretch across the yard. This discarded material is collected and carried by conveyor, where it is blended with pure silica sand and other additives like sodium carbonate. This careful mixture not only recycles the old glass, but also lowers the required melting temperature, drastically reducing the energy needed for production. Once blended, the uniform mass is sent into a fusion furnace, an immense thermal chamber running non-stop at nearly 1,600 degrees Celsius. Over the course of a full 24 hours, the material melts and fuses completely. The process yields a steady, uninterrupted stream of molten glass with exceptional clarity and viscosity, ready for shaping into flat panels. From the furnace, the molten glass is not shaped by blowing, but through a specialized technique known as the float method. A continuous stream is gently poured onto the surface of a vast molten tin bath. Because of the difference in density, the liquid glass floats and spreads naturally, leveling itself into a perfectly flat sheet with incredibly smooth parallel surfaces. As the glass ribbon flows forward, it enters zones with carefully controlled temperatures. This allows it to cool evenly without warping, preserving its flawless shape and crystal clear appearance. Leaving the tin bath, the sheets move along a long conveyor system, still holding a gentle warmth from the earlier stages. Here, precision takes center stage as robotic arms glide into action. Using diamond-tipped blades or laser tools, they slice the glass with incredible speed and accuracy. Each cut is executed to exact specifications, ensuring clean edges without causing cracks, chips, or surface stress, preparing the sheets for their final dimensions with surgical finesse. After being cut, the panels have rough, sharp edges that fail to meet aesthetic and safety standards. To resolve this, each panel is sent to a specialized edge polishing machine. There, high-speed abrasive wheels work to smooth every side with consistent pressure, rounding out the corners and refining the shape with pinpoint precision. The end result is a glass panel that is not only visually clean, but also safe to handle, transport, and install. To confirm this, samples are taken to a testing room to check their hardness and impact resistance. If the glass cracks in a spiderweb pattern, but does not shatter into sharp, dangerous pieces, it is considered safe. This type of breakage means the panel meets established safety standards for everyday use. Finally, the panels that pass all quality checks are carefully lifted by robotic arms and stacked neatly on specialized racks. Protective layers are placed between each sheet to prevent scratches or impact damage. Once secured, the entire stack is moved to the loading area, awaiting its journey to factories, construction sites, and stores around the world. It is born in fire, yet its destiny is to hold back the wind and rain. This remarkable path, guided by intense heat and exacting precision, reveals a story of pure transformation from glowing, molten fragments into immense, flawless panels. Every stage is a testament to human ingenuity, a dance of craftsmanship that unfolds in workshops and factories across the globe. It is a journey that concludes not in the furnace, but in the countless homes and storefronts that depend on its strength and clarity.